Hello everyone, my name is SHARMA and today I am going to tell how to write a program that print Armstrong numbers between two given numbers. So yeah, first we will know what is an Armstrong number. So an Armstrong number is a number that is equal to the sum of its own digits, each raised to the power of the number of digits. So basically like 153 is an Armstrong number. How it is an Armstrong number? 153 is an 3-digit number. So 1 raised to the power 3, that is 1, plus 5 raised to the power 3, that is 125. 125, and then 3 raised to the power 3, that is 27. So you are taking all the sum, that is equal to 153, which is equal to the original numbers. So 153 is an Armstrong number. So we will first see what is the idea of the program. Basically we have to check Armstrong number between two given numbers, like we are given two numbers, 100 and 1000. So we have to check how many Armstrong number lie between these two numbers, which are 1 and which is 100 and 1000. So yeah, for we will check individually for each number that is lying between these two numbers. So we will take a loop that runs from the smaller number to the larger number, and it increments by one. So each time it checks an individual number for whether it is an Armstrong number or not. So that is, first we will input the two numbers between which we have to print Armstrong numbers. Then we will run a loop which will individually check each number for Armstrong number. So for this, and how to check whether a number is an Armstrong number or not. So first we will calculate the number of digits in the given number. And how to do that, like we are given a number 143. 143 is a number, so we know it is a 3-digit number. So how to check it? So we will initialize a variable counter which has a value 0, an int variable counter which is initialized with the value 0, and we will take a loop which in the loop, in each iteration, the value of the number would be updated by the number divided by 10, and in each iteration the counter variable would increase by 1. So by this way, till the number becomes 0, the loop will run and it will give the number of digits. For example, in the first iteration, the counter variable value becomes 1, and then the number value would update to 40. And in the next iteration, the counter variable would become, like here the counter variable was 1, the counter variable would become 2, and the value stored in the number would be 1. And in the third iteration, the counter variable would become 3, and the value stored in the number would be 0. So the loop will exit. So the counter variable, the value finally stored in the counter variable would be 3, which is the number of the digits. And then we will extract each digit of the number. So we will use another loop. So like we have the same number 143. So how to extract the digit? So we will be extracting last digit of the number in the each iteration, and after each iteration we would again update the number to be number divided by 10. So in this way, in the first iteration, like we will extracting the last digit, that would be extracted by taking the remainder when the number is divided by 10. So if 143 is divided by 10, the remainder would be 3. And in the same iteration, what we'll be doing, we have initialized a variable sum which has a value 0. So the sum would get updated by sum plus the number which we have extracted raised to the total number of digits. So like here 3 raised to the power 3. So after the first iteration, the value of the sum would be this, and the number would be updated to 40. So in the next iteration, 14 divided by 10 would give us the remainder 4. So sum would get updated to sum which has the value 3 raised to the power 3 plus 4 raised to the power 3, and the number would be updated to 1. So in the next iteration, 1 divided by 10 will give the remainder 1. So 1 raised to the power 3. So this would be the sum after the iteration, because after this iteration the number would become 0, so the loop will terminate. So like this way. Then we will extract each digit of the number and calculate the value of the digit raised to the number of digits using the power function, which is included in the CMath library. So we have to include that library in our program. For extracting the digit, what we will do, we will run a loop in which every time the remainder on dividing by 10 will give the last digit of the number, and each time we will change the value of the number by dividing it by 10. Then we will store this result in a variable named sum, initialized with the value 0. At last, and to check whether the number is Armstrong number or not, we will check whether this sum is equal to the original number or not. If it is equal, we will print that this number is an Armstrong number, and if it is not, we will skip that number and go to the next number. So here is the program for that. First line is include IOStream, which includes the IOStream library, which is basically for input and output purposes. Then include CMath library, which is used for basic mathematical functions, like we have used the power function here, so we have to include this library. Then using namespace standard and int main, we can use void main instead of int main because we are not returning anything from this function. So yeah, this can be done. So we are first asking the user to enter the two numbers which are of the int type, int n1 and int n2, and we are taking the input using the cin function, cin n1, cin n2, and then we are using the loop for int I is equals to n1 and I less than equal to n2, I plus plus. This loop is used for checking the each number for whether the number is Armstrong number or not. And then we are initializing these variables, and these variables are initialized inside the loop because every time for the new number we have to check this again. So yeah, if this is written outside the loop, so the value of these variables would not be updated to 0 every time for each individual number. So yeah, this can give an logical error, so we have to keep that in mind. So yeah, int order for checking the number of digits, and int sum for storing the sum, and int temp is an temporary variable that would store that number because we are performing calculation on this number, so every time the value of the number would get updated, so it is better to store that number in a temporary variable on which the calculations can be performed. So yeah, this part of the while loop, this is used for calculating the number of digits. So yeah, while temp is greater than 0, order plus plus, and temp equal to temp divided by 10. So each time of the iteration we are updating the value of the temp. So yeah, this loop would give the number of digits. And then again we are initializing a variable count with the number, original number, and then int digit that would store the last digit of the number. So while count is positive, digit is equals to count mod 10. This gives the remainder. This gives the remainder or the last digit of the number. And then we will be updating the value of the sum. That would be sum equal to sum plus this function we are using. This calculates basically the first input, like the digit raised to the power order. This would give digit raised to the power order. So yeah, if we have like two numbers, like we have to calculate 3 raised to the power 2. So this would be power, which is the power function POW 3 comma 2. So yeah, in this way we have to calculate digit raised to the power order, which is the number of the digits in the given number. So yeah, we will be doing like this: power digit comma order, and then after each iteration we will update in the value of the count, count equal to count divided by 10. And at last we will be checking if sum is equals to I, then see out I, basically the number, is an Armstrong number. It will be printing that this particular number is an Armstrong number, and endl, which gives us to the next line. So yeah, this is the whole code of the program, and we will run it. So we input two numbers, 100 and 1000. So these all are the Armstrong number between these two given numbers: 153, 370, 371, and 407. So these are all the Armstrong numbers between these two numbers. So yeah, this was the basic idea of the program and the whole code and the output. Thank you.